This D-News episode is brought to you by Domain.com. Science is awesome. It's literally the coolest thing in the universe. And I literally mean literally. Hey there, cool cats. Julian here for D-News. Winter is coming, and the North remembers the familiar chill as the temperatures drop and everyone bundles up and wishes that hot, sticky, uncomfortable summer would come back. But you know where it's been really cold for the last 15 days? Italy. Scientists at the Cryogenic Underground Observatory for Rare Events, or CUORE, have cooled a 400-kilogram copper cubic meter to 0.006 degrees above absolute zero. That's negative 273.144 Celsius, or what Canadians would call chilly. They plan on using this block to detect rare radioactivity, including the as-yet theoretical neutrinoless double beta decay. And how will they detect this radiation? Why, when it heats tellurium dioxide crystals, of course. Do you ever get the feeling that scientists got into the field just so they could give things bitchin' names? But while this is the closest something that big and voluminous has gotten to 0 Kelvin, it's not the coolest ever, not even close. Researchers at Yale have used lasers on molecules suspended in magnetic fields to slow simple strontium monofluoride molecules to 0.0025 Kelvin. That's the coolest a molecule has ever gotten. That's almost as chill as a bro named Chad wearing an upside-down visor. But nothing compares to what the YKI group in Sweden produced in 2010. They also used magneto-optical trapping to cool rhodium to 100 picokelvin, or 0.000000001 degrees. It's the current world record, and for all we know, it's the current universe record as well. They aren't just doing this because it's mind-blowing and awesome, though that's all the reason I really need. Matter at such low temperatures behaves in new and exciting ways. Remember, temperature is literally how fast atoms are moving, with 0 Kelvin meaning they stop completely. That's theoretically impossible, but when they get close, instead of bouncing around at random, some elements move all together as though they're one giant atom. It's called a bose-einstein condensate, and it's a whole different state of matter from gas, liquid, solid, or plasma. BECs are useful because since they act as giant atoms, they make it easier to observe quantum effects, which helps test assumptions we make about quantum mechanics. BECs have also been used to slow light itself to a crawl. A Harvard team has used a BEC of sodium to slow light, which travels at over 1 billion kilometers an hour, to just 25 kilometers per hour. So if anyone ever tells you science isn't cool, they couldn't possibly be more wrong. Hey, you want to hear some more mind-blowing numbers? How about 1 million? As in, D-News has 1 million subscribers. And as a special treat for you, you can find out what Trace and Tara are like behind the scenes here. What do you think is the coolest thing about science? Figuratively, obviously. Well, let us know in the comments, and I'll see you next time on D-News.